Hey guys, Mr. Riz here to help you out with the 212 Part 3. This is the asymmetric encryption. When we've been doing all of our ciphers, all of them have been example of private key encryption because the same key could be used to both encrypt and decrypt. So if you remember like a shift slider, if we knew that the key the shift was five letters to the right, we could use that same number to decrypt it. So that same number, that same key, whatever it was used to encrypt, could also decrypt. All right. So, however, there's another type of encryption known as public key encryption. So, unlike private key encryption, what we did before, where both the sender and the receiver share one confidential key, there's one key that opens and unlocks the door, locks and unlocks the door. A public key encryption is where there are two pair keys. So one key is used to encrypt the message, and another key, a separate one, is used to decrypt it. So if you think about like almost kind of like one key can only lock the door, it cannot unlock the door, and then the other key can only unlock it, it cannot lock it. All right. So one key is shared publicly while the other key is kept privately. This encryption method is known as asymmetric encryption. All right, asymmetric encryption can be used for the following purposes. So basically to encrypt a message with someone's public key, so only they will be able to read the message. So say you have a company and you want to send a message to one specific person, you want to make sure that nobody else can read that message. All right, that would be using their public key to share that. All right. And next, we could also encrypt a message with your own private key. So anybody with the message will know the message came from you using your decrypted public key. So yeah, there we go. So there's two different ways we can do this. So something to think about here, or just some reflection here. Suppose you want to get a message from Amazon, or you get one from Amazon, and it looks like just gibberish. It's just you can't understand it. A whole bunch of code, whatever. Amazon's public key turns that into English. So I think about they will send a message out. It's all decrypted. You don't know what it says, but if you use their public key, you can decrypt it. You can read it out. So let's try to explain why you should increase your confidence that Amazon actually sent that message. Well, if you have Amazon's public key, you are the only one to know, or you're able to decrypt that message using their public key. If you try to use somebody else's public key, say you try to use Home Depot's public key on that encrypted, mixed up message, and it worked, well, then it came from Home Depot. So you can get decrypted messages from all over. It's like getting a word puzzle from all over. And whose ever public key can decode it, that's who sent it. All right. So unlike symmetric key encryption, where the same key can be used for password or passphrase, the pair keys in asymmetric encryption are large numbers associated or large associated numbers that are randomly chosen. So we just have these numbers that are just super big and they're just chose together, paired together, and it just increases decreases the probability that somebody could just guess them right. All right, they are generated using a really complicated mathematical formula and only work when they are paired together. So using a public key encryption algorithm, the owner of that paired key shares one of them public key. So, okay, everybody wants to know, okay, what's your public key? So if you get a message from me, you can use my public key to decrypt it, and it keeps the other one or the private key secret. We're going to try to practice this in this next activity, just sending messages between one another. All right, you will now use an asymmetric encryption to encrypt and decrypt messages with a partner. You will use an algorithm called the RSA algorithm, commonly used as an algorithm to securing internet traffic. Okay, the code provided below, or actually it's, I believe, in our we have the RSA encrypt and RSS decrypt, and even the RSA PY, is in our library here. This library uses programs necessary to encrypt and decrypt. So we can do all that right here, and it's already set through. Somebody has put all the math in here and figured it out, and we'll go through all that. So what we want to do first is we want to run the generate keys program that we downloaded at the very beginning of the 212 activity. And we're going to record all three keys provided. In fact, we are going to put that into the the discussion board at the post. You know what? And I will pause this and edit that to make sure it says it. All right, so yeah, we want to make sure we post this through. So I'm going to go ahead and do this, and you guys will see. You should see it at the end. So we need to use the run generated keys.py here. What I'm going to do is I'm just going to do Control A to copy this. And if you remember, we have our main py. I'm just going to go ahead. I guess we had our secret message that we were doing from before, and get rid of that. So this is at the end. I guess we could just paste over, but in case we ever need that main py file again, I'm just having it up here. So I'm going to go ahead and run this now. Remember our main py that was originally there, the cipher one. Ooh, didn't need to click share. It has this encrypt or decrypt message. It doesn't matter. This is with a single key encrypt. I'm just going to type the message. Sub shifted over to, okay, whatever. Okay, so after that, our generated key comes out now, and I'm going to share these three things. So let's see if I can just paste that in the reply. My public key is 8461. My private key is 6181, and my modulus is 21509. Okay, and I'm just going to go ahead, post a reply here. Okay. All right, so let's see. If we look at those, the first two numbers here, which pop up, the 137 and 157, you have different ones, are used to generate the keys. The public key and the modulus are shared in the computer document discussed by your teacher. So you can actually see, you know, over here in the RSA, it uses this program and uses those numbers that we get. Those are some of the prime numbers there that pop up, and then it goes through mathematically. There's a whole bunch of complicated stuff that really, if you really want to look into, we can talk about, but it uses those to help generate the private key. And we're going to keep the private key for yourself, but what we're going to have to do, since we're going to do this online, and I need to double check that you're doing it, just share your private key as well, because I'm going to use that to help to double check that you did your work right. So normally, like if we were trying to do this as one big group activity, we'd keep our private key private, but we're going to do this online, and then we're just going to switch it up. I'm going to double check that this works right. Okay, so we got our stuff out that looks like this. So we publish our public key and also our modulus, and we put our private key on here, and you share their private key with me, just so I can know that. We're going to select another student to message. So I'm going to go through and make another test student here. So I'm going to put another one on here. So let me generate the keys again, just to show you guys here. All right, so this is just main py file running again, whatever, AAA. I'm going to shift that over to spot CCC. Okay, so I'm going to put here, I don't think I can copy this, can I? But we'll put another one. Let's post another reply. Example student video. Oh, cool. That worked out great. All right. So you're going to find somebody in the discussion board, and you know, whatever they are, and we're going to try to copy their public key and their modulus. So I'm going to take my example student here. I'm going to take their public key and their modulus. I will use those. Okay. We're going to run the RSA encrypt code now. So I'm going to go ahead and copy this in, Control C. I'm going to go to my main py file, and you know, I really don't need all that encrypt decrypt stuff, but oh, you know, I forgot to paste that in. All right, we're going to run the RSA encrypt. Let's run that again. Maybe. Okay, here we go. All right, so going through the main py, do I want to encrypt, message, A, one spot, there we go, it goes to B. Okay, enter the encryption key. So the encryption key that we are going to use is their public key. So I'm going to take this person's public key here and type it into the encryption key, 22431, and enter their modulus, 33 33823. And I'm going to enter a message to encrypt to them. So I'm going to say, hey, dude. You are pretty cool. All right, press enter. So we get this encrypted message here. And what they basically do is using your encryption key and your modulus and the characters, it all mixes it up, and we basically change each character to a set number. Now, those set of numbers only match with the encryption key and the modulus, and we can only decode those with the private keys. Okay, so this is what we're going to do. We're going to send that encryption key to that person. So you're going to go ahead and copy this code here. Oh, I didn't mean to click paste. Oh, that's interesting how it worked like that. So I'm going to click copy. And we're going to go through to this person here, and you're going to reply to them, paste your encrypted message. Okay. So next, what we need to do here is to then go through and see, we get a message. So we encrypt it, we record the create and decree with asymmetric. We're going to send that to the person. All right. So if somebody takes this message here, if some random person's just looking online and they see this message, can they decrypt it? I mean, theoretically, yes, but they need to have the person's private key to decrypt that. So if we kept our private key separate, there'd be no way that somebody else in the classroom could figure out what that says. Okay. So next, what we need to do is we should probably respond to that message. So we are going to decrypt. So the second part of this activity is to have you guys go through, and any message sent to you, you have to decrypt and then reply. But you're going to reply in just plain old English. And so what we're going to have to do now is let's run the decryption. So just like how we did the encrypt, I'm going to go through and get the decrypt. All right, I'm going to copy this code here, Control C. I'm going to go to the main py file and get rid of all that encrypt code. All right, and run it. Now the main py file, if you remember, still has, you know, I guess we didn't use it at all, but I just never want to get rid of it in case I need it back for, you know, an example to show in class. Come on, let's run this. Oh, did I clear this off? There we go. Let's run this. Okay, let's encrypt a message, enter a message, encrypted one, let's be, okay. Enter the decryption key. So if we want to enter the decryption key, all right, I'm going to enter the private key, 33111, and enter the modulus 33823. What message do we want to decrypt? And let's see if we can Control C, copy this, and paste that in. Cannot, but can I do? Ooh, this is where it's a little complicated here. No. Okay, let me pause this. We might have to use this module here. I want to double check we can do this. All right, so I think this is where we have to get a little fancy with Ripple here to make sure we can go over this. So after we get the encrypted message, it's not working. Let's do a little fancy thing. We're going to do encrypted message equals, and we are just going to do a string of that code. So I just copy paste that in. So I added to the decryption message here just the encrypted message. So we still have our input, which we won't be able to type. So remember, this first part is just the main py file running. So okay, encrypt. You probably don't need to have this. What's the message? Okay. Decryption key is their private key 33111, and the modulus is 33823. Enter the message they want to decrypt. Oh, it says no brackets. Oh, you know what? This is not even going to work here. All right, because it needs to have no brackets here. And see that? Get rid of our brackets in our encrypted message, and let's run that again. All right, yeah, this is the main py file again. Oh, we want to encrypt, whatever, enter a message, A1, whatever. Decryption key, let's try that again. 33111, modulus 33823, message with no brackets. This is basically running in line 75 here, which we don't need. I can just press enter here. Next, it's going to take your encrypted message here. It says, H dude, actually, does that say hi dude? It should say, oh, you know what? I started like deleting and it didn't look backwards. So H dude, you are pretty cool. So I got their encrypted message and I can reply here, be like, thanks. I think you are cool too. Supposed to reply. So I'm basically going to be looking for three things. One, on this activity, you post your public key, private key, and your modulus. And normally we'd keep our private key separate, but I'm going to go through and double check that you did the activity right. So I'm going to use your private key when I check to make sure that you're actually replying to the message. That way, you don't just like randomly quote something back. Something like types in like, hey, what's your favorite sport? And you reply like, peanut butter jelly sandwiches taste good. Just because you think like you don't figure out how to decrypt. So post your public key, private key, and your modulus. You are going to then pick somebody else randomly in the classroom, and there's already two up there. There's me and the example student that I used. You are going to use their public key to send them a message. And then once ever you get a message from somebody, you're going to use your private key to decrypt that. I want you guys to reply to at least one response. Now, I'll try to do more. I think it's fun to kind of practice that. So you'll use your private key to decrypt the message and then just post a normal text reply to that. I think that'd be a little bit easier. That way you don't have to try to figure out who that person is and then use a private key to figure out what theirs is. So, which would typically normally do that. All right, guys. So hopefully you have some fun with this activity. You can talk to some people who are not normally in the classroom with you, and I'll see you guys later. Have a great one.